All right, so we've looked at graphing either by hand or using our calculator to solve a system of linear equations, but we can also do it by pen and paper using algebra, which will also yield an exact solution. So if you got like a long repeating decimal, or maybe not a repeating decimal, maybe an irrational number, algebra will help us to determine what that value is as a fraction. So there's two ways that we're going to do this. The first one is called substitution. So what we're going to do is, we're going to make one of our equations have y equals blah, 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 or x equals blah, blah, blah. And then in our other equation, x plus y equals 4, I don't know, we'll take our blah, blah, blah for y and substitute it in. So x plus whatever y equaled here equals 4. And what we'll get is just one variable, and we need only one unknown variable in our equation to solve it. The best way to know how to do this is just to practice it and to do an actual example. So what we're going to do is we're going to solve this linear system. So I'm going to call this like my red equation and my blue equation. Verify your answer. So I'm going to look at the equations and I'm going to decide which one might be easier to move things to one side to have one variable by itself, or if one variable is already by itself. So in 5x plus y equals 4, one variable is not by itself. However, if I were to choose a variable here, I would choose y because there's no coefficient and I would solve for y. However, if I look at my blue equation, y equals negative x plus 2. Y is by itself. It has a coefficient of 1. So I am ready to sub in my blue equation to my red equation. So I'm going to say that we have 5x, and then instead of y, I'm going to sub in what y equals here. Y equals negative x plus 2. And that equals 4. So all I did was I took what y equals here, subbed it into my equation, and kept everything else the same. All right, I put it in brackets because I want to make sure that the signs are proper. I'm just going to get rid of my brackets now. So 5x plus negative x is negative x, and plus 2 is plus 2 equals 4. So 5x take away x is 4x, and technically I can move 2 to the other side by subtracting 2, so 4x equals 2. X, to get by itself, we need to divide by 4, and we can see that x equals 1/2 as our answer. So now that we know that x equals 1/2, we can sub our value of x into either equation and solve for y. It really doesn't matter. I typically just go and sub into my very first equation. So 5x, now that we know that x is 1/2, we'll sub that in, plus just regular y equals 4. All right. And now we have only one variable here, and we can solve for what the value of y is when x equals 1/2. So 5 times 1/2 is 5/2 plus y equals 4. I need to subtract 5/2 from both sides. Oopsie, 5/2. And I get that y is equal to, now I'm going to change 4 into a fraction over 2, which is 8/2, take away 5/2. So y equals 3/2. So this is our coordinate that will work. It would be where our graphs cross. Now, I've used this equation to solve for y. I've used a combination of them to solve for my x initially. What I'm going to do is I'm going to use not the one that I used to solve for y, but the other one now, and I'm going to check my work. Okay, so always use the other equation and what's really written in the question. If you've manipulated your equation at all, always go back to what's written in the question, and I'll give you an example of this a little bit later on. Okay, so we're going to sub into this one with our actual values just to check. So 3/2 equals negative 1/2 plus 2. 3/2 is equal to negative 1/2 plus, I'm going to say 4/2. 3/2 equals 3/2. So we did it right. This is just our check. All right, again, you could also check by graphing. You could put this into your calculator if you'd like. Solve another linear system by substitution. All right. Well, what I see here is that all of my equations, or both of my equations, are not solved for a particular variable. So we don't have y equals or x equals. We're going to have to move things around. But it doesn't really matter who you pick now. So just rearrange one equation to isolate for a variable. So I'm going to isolate for, I don't know, let's say x this time, because we had y by itself last time. And I'm going to do that to our first equation here. So 5x minus 3y equals 18. So I'm going to add 3y to both sides. I'm going to get 5x equals 18 plus 3y, and I need to divide both sides by 5. So x equals 18 over 5 plus 3 over 5y. Now we're going to sub that into our other equation now. So 4 times x, which was 18 over 5 plus 3 over 5y. Now notice we've kept our coefficient and we're going to multiply it by everything that equals x here. So we need to put brackets. Minus 6y equals 18. All right. This looks like it's going to be a lot of fraction work. So 4 times 18 is 72 over 5 plus 12 over 5y minus 6y equals 18. So I'm going to subtract 72 over 5 from both sides. What a gross fraction. And I'm going to turn my 6y into a fraction over 5. So multiplying 6 by 5, I get 12 over 5y minus 30 over 5y. And this equals 90 over 5, which is 18, minus 72 over 5. Are we having fun yet? Okay, 12 take away 30 is negative 18 over 5y. And 90 take away 72 is 18 over 5. So we can multiply both sides by 5 to get rid of our denominator. I'll just do that in a different color here. So times 5 and times 5, and that actually just cancels this. And I need to divide both sides by negative 18 to get just one y by itself. So 18 divided by negative 18, we get that y is equal to negative 1. Ugh, that was a lot of work to get there. So brush up on adding, subtracting, multiplying, and dividing fractions to become more comfortable with this. Okay, I'm going to sub this into either equation to solve for x now. So I'm going to solve that into my first equation. So 5x minus 3 times y, which is negative 1, equals 18. So 5x plus 3 equals 18. Take away 3 from both sides. I get that 5x equals 15. Goodness. Divide by 5. Divide by 5. X equals 3. And last but not least, if you want to check your work, you can either graph both of these lines or you can sub into the other equation. So because we used our first equation to solve for our second variable, we're going to use our second equation to check. So 4 times x, which was 3, minus 6 times y, which was negative 1, equals 18. So 12 plus 6 equals 18. 18 equals 18. Excellent. So these two linear systems have the same graphs and the same solution. X equals 1 and y equals 2. Let's take a quick look at them. So our first one has 1/3 x minus 1/3 y equals negative 1/3. In our second system that had the exact same solution, this line is x minus y equals negative 1. we can just see that we've multiplied this equation by 3. In our second line, x over 2 plus y equals 5 over 2. Over here, it looks like the same equation. We've just multiplied the entire thing by 2. So system A, we can multiply the first equation by 3 and the second equation by 2 to write equivalent equations with integer coefficients. The result is the equations in system B. So we're just going to show that here. So 1/3 x minus 1/3 y equals negative 1/3. If I multiply this whole thing by 3, I get, 3 over 3 is 1, so x. 3 over 3 is 1 here, so minus y. And 3 over 3 is negative 1. So that's the same. Therefore, these are equivalent. Same thing in our second equation, x over 2 plus y equals 5 over 2. We multiply this whole equation by 2. So 2x over 2, the 2's cancel. So we get x. And then we multiply, we get plus 2y. And 5 times 2 is 10, divided by 2 is 5 still. Again, these are equivalent. So a system of equivalent equations is called an equivalent linear system and has the same solution as the original system. So when an equation in a linear system has coefficients or a constant term that are fractions, we can actually multiply by a common denominator to write an equivalent equation with integers. And this can be helpful just to reduce the number of adding, subtracting, multiplying, and dividing of fractions that we end up doing. So example 3 has some crazy fractions here. So what I did is I'm going to multiply our first equation to get rid of both denominators. So to do that, I would need to multiply by 2 and 5. So it's the same as multiplying by 10. So if I multiply by 10, I get 10 over 2, which is 5x, minus 10 times 4 is 40, divided by 5 is 8y, which equals negative 20. If I would like to multiply both the 4 and the 8 out, I need to multiply by 8 here. So 8y is equal to 2x minus 3. So these are my two equations that we can work with. Now, remember, we wanted to get one coefficient by itself. Technically, in this equation, y is close to being by itself. It has a coefficient, and typically I would try and divide it out and put an 8 over here. However, if you notice in our first equation here, 8y appears, so it has the same coefficient as this one. The negative is fine. I know that it would be negative 8 and positive 8, but we can leave the negative out of it. So what I can do here is I can take my first equation, I can take 5x, and we can subtract what 8y is equal to, which is 2x minus 3, and that equals negative 20. So in this example already, we've multiplied out our fractions, and we've used a coefficient with our variable to sub in just to simplify. If you don't like what I did, go ahead and just solve for y and sub in, and you'll still get the exact same answer. We've just tried to simplify our work a little bit. So 5x take away 2x is 3x. And we need to subtract negative 3. Again, we're distributing this negative through. So subtracting negative 3, we get plus 3 equals negative 20. All right, subtract 3 from both sides. We get that 3x equals negative 23. X by itself, I need to divide both sides by 3. I get that x is equal to negative 23 over 3. A nasty answer. However, it's an exact answer. We would get a random fraction or repeating number, if we were to try and solve this in our calculator. Okay, so we know what x equals. Let's sub into either of our equations here to solve. So typically what I would do is sub into one of these. Remember that if you've made an error in multiplying this out, there will be an error here. So it's a bit of a risk. You have to trust your mathematical ability, because if you've made an error in this, you're going to continue that error throughout. So a safe bet is to sub back into here, but again, we have really nasty fractions happening here, so I'm going to sub into this one to hopefully kind of mitigate that. I trust my own work. Okay, so let's sub into our first equation. So 5x, where x is negative 23 over 3 minus 8y equals negative 20. 5 times negative 23 is negative 115 over 3 minus 8y equals negative 20. So I'm going to add 115 over 3 to both sides. And I get that negative 8y is equal to negative 60 over 3, which is negative 20, plus 115 over 3. So negative 60 plus 115, I get that negative 8y is equal to 55 over 3. Now I can't actually reduce that at all, so we need to divide both sides by negative 8. And so that's like multiplying by negative 8 in our denominator here. So our answer, y is equal to 55 over negative 24. So I can put the negative up top, it doesn't matter. Okay, really gross answers again. This one is a repeating decimal, but it would be tricky to solve for in our calculator. So let's check our work by subbing into the other equation. So I used equation 1 to solve for my second variable. I'm going to use my second equation here to check my work. So 8 times y, which was negative 55 over 24, is equal to 2 times x, negative 23 over 3 minus 3. All right, 8 times negative 55 is negative 440 over 24, which equals 23 times 2 is 46 over 3. And I'm going to make this 9 over 3 so I can combine. So negative 440 over 24 is equal to negative 46 minus 9 is negative 55 over 3. Now, if I want to make these equivalent, I need to make the denominators equivalent just to compare. So I'm going to multiply by 8 top and bottom. Negative 55 times 8 is negative 440 over 24, which equals the left side here. So we've done it. Gross numbers, and this is why algebra is important, is because we wouldn't be able to find this exact value by graphing, no matter how accurate we were on our own graph paper or with our calculator. Our calculator does not give us a fractional value.